Hi, my name is Rubens. I'm a digital project manager, uh, or you can also know as a kind of P manager with project management. I'm working in construction over 20 years so far. I worked on site, construction site, design, and always back and forth. And today I would like to talk about those two things together. So how we can go from design dreams to reality checks, the power of construction verification. Okay, so let's go. So I'm calling it design dreams to be provocative because in the design world, like when we have models and drawings, everything is perfect. It's ideal. Like every line it's straight, every angle it's perfect. So that's how we design. So that's the nature of computer. That's the nature of drawings. You won't design something that's not working in the first place. So we try to bring this ideal world that's in design. But that's everybody know that's not the reality. The reality it's ugly. It's much more complex. So design it's a like a simplification. How we get what we want to do to go. So as you know, like construction, it's a very complex activity. So it's subject to weather. Like you depend on like a high complex and collaborative teams, materials, logistics. There are construction errors, so it's very complex. So just to add another point, like how give some numbers, how complex is this activity? So let's say if we use railway stages, let's say design is roughly 5 stages, and then construction, like of course, depends on the size of construction, could go for 16 stages. And then we have more equipment, more materials, budgets are much higher, much bigger, and team size, the team management, the supply chain. So, you know, construction, it's much more complex activity than the design. I know designers who say, "Oh, but I have to solve a lot of problems and calculations." Yes, but construction it's also really complex, and we are not dealing with just the drawings and like in office. It's there, it's on site. So more stages, more equipment, more costs, more teams, and a more complex supply chain. So, why do I need construction verification? Okay, because things are not perfect. So everybody knows, like, the more like specialized the team is, like we have a very high qualified team, we never gonna get exactly things right. Okay, so here just some examples. So the columns in yellow, they are off the position, so they're not built exactly as per design. Green, it's okay within the design tolerance. And the other side, we see like after each stage of the construction, we have a huge complexity. So if we go those columns, they are off position. So the next stage, it won't match with that ideal design we dreamed before. So we need to keep adjusting. So that's why we need construction verification, because we need to bring reality back to the design. So we marry design and construction. So when why do I need to coordinate as-built models? Then again, like because when you're doing the design, you're coordinating, let's say, architecture, you're coordinating mechanical, MEP, and structural, and all of them, all those design elements, they are in their ideal situation. So they're perfect in terms of like the design wise. But when we go to construction, so let's say we have the structure. So the structure is there. So that design, the structural design, it's not reflecting reality anymore. So I can't. So when I go build the next stage, the MEP, I now I have a new model. That's a model it's the reality. So if I come with my ideal MEP against my to trying to connect with my reality uh, structural model, like they won't fit perfect. So we need to make adjustments. So that's why, like, we need to be ahead of the construction stages. We need to do a construction design coordination. I know, like, you finish, oh, but I already finished my design. Yes, but we need to keep adjusting because reality it's different. And we need to reduce and amend errors. So if a column is off position, as we shown before, so what you're going to do with your fire ducts, and so what are you going to do with that? So you're going to try to cut the column, or you're going to have to move the pipes. So have to move the pipes. So, but you need to know ahead. So you need to be ahead of construction for that. So, in what's the power? The power of construction verification. Oh, construction verification. So you see in the image, there is an example there. So it was design a wall with openings, and but somehow, somewhat, for some reason, openings are not exactly as the design, or they are exactly as per design, but the design changed. So they are not the what is in the future. That's the model, the next stage. It's not marrying, like it's not connecting, it's not fitting, it's clashing with the reality. So that's why we need to be ahead. So this curve, like the beam flow curve, everybody like you have seen this curve millions of times. The green line is like, oh, the beam flow is ahead of the construction. But that's not just the beginning. Like, we need to keep ahead every time. We need to adjust the construction model, the as-built model, so we always ahead. So in this case, the openings are not fit for the design. So what you're gonna do? So you might go on site and create new openings. So for that, you need to talk with the structural design. So they have to check if it's possible. If it's not, designer enforcement, and you are ahead. You are ahead of the construction, so you are saving time. Whenever those pipes get to the site, we know this problem is already solved. So like, and we don't want to wait. The workers are there trying to fit the pipe and say like, oh, actually it's not working. Then so they have to lay down their tools and wait and like go to the engineer. It's a hell of a huge problem. So you don't want that. So in how we do that, how we do this verification, how we keep ahead of the construction. So there are a lot of tools. So the first thing is real-time verification. So you can check while construction is happening. So let's say you go back to this one. So while they were building this wall, if someone had AR goggles, so they would overlay the model and the construction site and whatever is there, they could have seen that, oh, there is a problem here. But let's say that was the design in time, that in that time. So AR would not capture that because this design was correct and the pipes are changed later on. So, and then you need the second phase, second part is a detail analysis. So you go there with your laser scan and you capture reality and update the as-built model, share with team so they can, before the next design stage, before to go to mechanical installation, they can check and say, oh, actually it's not, something happened here, so we need to talk. So that's why we need fast collaboration. And how we do fast collaboration, there are several softwares that can do this fast collaboration because point clouds they're huge files and they're very complex to deal with point clouds and models. But there are softwares that can do this verification for you and give you like a very quick reports. So talking about the AR, VR real time. So there are also several tools now, like you can overlay um, the reality with the model, and they use also high accurate GPS to give you like measurements, so you know, oh, this pipe is in the correct. There are they like digging the correct place, so you can check that on real time and make your adjustments, verify, adjust, and reduce errors. And when it comes to okay, verification and adjustment, so you can automate these analysis in also almost real time. So when you get the point cloud, use the softwares and cross-check that. And those softwares, they can analyze and see, oh, this pipe should be here, and it's a 20 millimeters off position, is half a meter, and move those elements to the as-built position. Once they move those elements, they automatically move these elements to as-built position. Once they move to as-built position, there you go. You have your as-built model. You share with the team and you rerun your clash detection and collaboration. So you'll be ahead of the construction. But and then people say, oh, that's all the future. No, it's not the future. All those tools, they are available now. So you have construction verification tools. So all those companies, they're like 10 years, 5 years, they're already available. So all those tools, all this workflow is already available. Oh, but why I haven't seen, are they like too expensive? No, like you just go ahead and have a look at them. They're not too expensive. And if you compare with the construction cost and the cost of those softwares and those workflow, you're going to see that's really worth it. And collaboration, how to incorporate as built into collaboration workflow. Again, like you already use Revit, you already use Navisworks, you know how it's possible to go with a laser scan and scan the construction site. So all those tools they are available. It's just a case of incorporate them into the workflow and do the analysis and take actions. So it's the same way you do your design coordination. This design coordination has to keep going during the construction phase. So you have an updated as-built model, and this as-built model is going to turn into your digital twin in the future when you finish your handover. So we are guaranteeing that the reality is turning into your dreams are turning into reality. Okay, your design is turning into reality. And what's the power of construction verification? It's to reduce errors. As I was showing before, like you can reduce errors during the process while you're there building. You can reduce errors using AR and VR and checking things in real time. And you can check to reduce errors after the construction. So you amend those errors, and the next stage is going to be built on top of the reality. And all those methods, when you know exactly what's on site, that's enable you to build using modern methods of constructions, MMC. Like so, you can have prefabrication, you can have structural prefabrication, you could have MEP prefabrication, and that's like offsite construction. As everybody knows, like reduce risks of accidents. So it's better for safety, it's better for costing, it's better for like the whole workflow, and gives you a better result as well. And again, like the digital twins, like once you have the model and it's accurate to reality, So this can be the basis for creating your digital twin and do facility management. So I see all the benefits here, and it's all available now. It's just a case you like see the benefits of that, integrate your workflow, and go ahead. Thank you for your time. If you have any questions, please let me know. I'm happy to help you and collaborate.